The dot product of two vectors, u and v, is given by u dot v, and that is equal to the horizontal component of u times the horizontal component of v plus the vertical component of u times the vertical component of v. So this is our product of horizontal components, and we're going to add to that the product of the vertical components. And that's what we call a dot product. Now, the dot product, u dot v means dot product. Now, the dot product is a way for us to compute angles between two vectors. So we're going to use the dot product for a very specific purpose. However, since we're talking about the dot product, let's talk about properties of a dot product. First of all, the dot product is a scalar. So it's going to be a scalar. It does not result in a vector. Okay, so when I take the product of two numbers plus the product of two numbers, I'm going to get a sum. When you add two numbers together, you get another number. So that's what we're going to end up having as a scalar. So when you take the dot product of two vectors, the vector goes away and all you have is a scalar. Now, properties of the dot product, u dot v is indeed equal to v dot u. So the commutative property does exist. If I take 0 and I multiply it through to the vector, not multiply it, if I take the dot product of 0 and a vector, I'm going to get 0, which is a scalar. Okay, the result of a dot product is a scalar. Okay, if I have u dot v plus w, that is indeed the same as u dot v plus u dot w. So it has some very similar properties of multiplication because in essence it involves multiplication. So in that case, let's see, the first property, second property, the third property, you can do the dot product twice and then add the two scalars. So you would have a scalar plus a scalar, which would result in a scalar. You could do it that way, or you could add the two vectors first and then simply do the dot product. If I take a vector and I calculate the dot product of the vector with itself, that is equal to the magnitude of the vector squared. And my fifth property, if I take some scalar that we'll call c, and I multiply it to u dot v, which is also a scalar, we're going to result in a scalar. So you could compute u dot v first, find that scalar, multiply it to c, or you can again do the associative property and multiply the scalar times vector u with the dot product of v, or u times the scalar times vector v. U dot product with the scalar times vector v. So this is the dot product. I keep saying multiplication, and it really is the dot product. We're going to think of it as multiplication though so much because that's exactly what we're doing. Is we're doing a lot of multiplying with the dot product, but there's that sum that's involved, and I'll show you right here. Here we've got find the dot product of each. So we're doing a lot of multiplying with the dot product. We're going to multiply the horizontal components. And then we're going to add to that the product of the vertical components. Oops. So we're going to have 4 times 2 is 8, right? 4 times 2 is 8. And then we're going to have 5 times 3. That's where the 15 is coming from. 8 plus 15 is 23, which is a scalar, not a vector. So now you try the next two. You can press pause, and then when you're ready to reveal the answer, you can come on back and check. I got 2 plus -2 is 0. And for the next one, I got 0 plus -6, which is -6. And all three of those are scalars because we computed the dot product, and the dot product results in a scalar. In the next video, we're going to use the dot product. So we're going to use the dot product with some of those properties that I just showed you.